do that.
Hello, my name is Olga Panfilova-Georgiou. Today on World Environment Day, I would like to talk about water as fundamental component of the environment. Water is crucial for sustaining ecosystems, regulating climate processes, and supporting human and, of course, economic activity. In Cyprus, water scarcity has become a persistent environmental concern, driven by many factors, not only anthropogenic, but also climate change, making an integrated water resource management essential for ensuring long-term sustainability and environmental resilience. Today, we are pleased to welcome a speaker who will help us explore this critical issue in more depth. Welcome, Professor Lang. It's a pleasure to have you with us today on World Environment Day.
Thank you very much, Olga.
Professor Lang Manfred Lang is a climate scientist with a strong focus on water and energy security. He was the founding director of the Energy, Environment and Water Research Center at the Cyprus Institute in 2007 and remains a professor there. He also directs the Future Earth MENA Regional Center and serves on the steering committee of Mediterranean Expert on Climate and Environmental Change. His research centers on climate change impacts, particularly water scarcity and renewable energy solutions in the MENA region. You also worked as director of the Arctic Center in Rovaniemi, Finland in the 90s and as professor of geophysics at the University of Münster in Germany for 12 years before he came to Cyprus. It's been quite a journey, Professor Lang. I hope that I didn't miss anything.
No, you didn't. It's fine. Thank you so much, Olga, for your nice introduction.
A bit of a background. I had the pleasure of meeting Professor Lang during his impressive and truly motivating presentation on water scarcity in Cyprus about 15 years ago. His insights left a very strong impression on me and motivated me and my family to review our habits in regard to water use and water consumption. Later, we both started volunteering for the Cyprus Rotary Pollinator Project. So when my sustainability team in Grand Font in Cyprus began considering themes for the Environment Day, and given how pressing the issue of water is for Cyprus, I couldn't miss the opportunity to invite you. Yes. So, Professor Lang, your extensive work on climate change impacts, especially in the MENA region, and your leadership at the Cyprus Institute has been instrumental in advancing research on water and energy security. Given your expertise on the matter, how do you assess the current status of water scarcity in Cyprus, and why is it considered one of the country's most urgent sustainability challenges?
Okay, Olga, in order to answer your question, which is well taken, let us take a look at some slides that I've prepared to try to understand what is happening. So now let's see if this works.
See.
Okay. So let's start by looking at the current climate conditions in the region or in the wider region of the Mediterranean basin. This somewhat messy looking slide here shows two things. It shows the mean annual global temperatures from the late 19th century until more or less today in green. And you see the wiggling curve, that's the annual values. And then you see a sort of smooth curve, that's the lighter green curve. On the other hand, you see a blue curve or two blue curves. And again, the wiggly curve shows the mean annual temperatures in the MENA region or in the Mediterranean, whereas the blue smooth curve shows a smooth representation of these temperatures. Now, as you can see, for quite some time, these two smooth curves more or less overlapped. However, as we enter the 1990s, you see that the two curves start to diverge. And actually, right now, we're seeing that the curves diverge by about half a degree. In other words, the Mediterranean mean annual temperatures by about half a degree above the global mean. Well, that doesn't sound too much. However, keep in mind, this is the mean annual temperatures. So, and we'll see that in a moment, we can expect that the summer temperatures, for instance, in the Mediterranean basin are much higher than the global mean. Now, this is the sort of broad view, and it has been sort of the reason for calling the Mediterranean a climate change hotspot. Now, if we take a look at Cyprus and how that plays out as for today and in the future, you see three different items here. We see that days with maximum temperatures above 35 degrees, which is pretty hot, today amount to about 60. So in other words, 60 days, we have pretty high temperatures. As we go into the future, and this is based on numerical modeling, you see that there is an increase of 42% in hot days at about mid-century, amounting to 85 very hot days. And as we go to the end of the century, we see actually a doubling of these hot days to about 120. So in other words, about 1/3 of the year, we're experiencing extremely hot days. Equally and similarly, when we look at so-called tropical nights, where we measure temperatures above 25 degrees Celsius, they're at present at about 75, increasing to about 120 at mid-century and to 165 by the end of the century. So it's not only the days that are particularly warm, it's also the nights. Now, if we take a look at water, here in particular, what's called dry spells, in other words, periods where virtually no rain falls at all. Today, we have about 100 days of these conditions. As we go to mid-century, there's a slight increase of 8%. But at the end of the century, we already have 120 days without any rain and any precipitation. Now, this is based on numerical climate modeling. And without going into too much detail, let me give you two examples of what temperatures will look like at the end of the century, now not just only for Cyprus, but for the entire Mediterranean basin. Now, the difference in the two pictures is the assumption on greenhouse gas emissions that we're seeing. The upper panel shows a fairly optimistic projection of greenhouse gas emissions, more or less staying at the same as we have today, or actually even slightly decreasing. The lower panel shows what is unfortunately actually much more likely. That's to say, a continued strong increase in emissions and therefore a strong increase in temperatures around the Mediterranean. The yellow numbers indicate actually the temperature that we're expecting, the future temperature that we're expecting for Cyprus, which one can see is sort of in the middle of the slide on the right. And for the optimistic scenario, we talk about 2 degrees increase in mean annual temperatures, whereas for the lower panel, the more realistic, unfortunately, we're seeing an increase in 5.5 degrees, which is actually really quite a bit. So that's what is in store for us. And I think, again, both in terms of temperatures and in terms of precipitation or water, the situation looks pretty grim. Um, I think we'll go on to the next question because I have more to say about water as we go along, Olga.
Um, okay, so Mediterranean area is heating faster than the global average by about 0.5 degrees Celsius, and Cyprus, being part of the Mediterranean, is affected by this increased heat as well. Cyprus is also, from what we see, is facing an increased shortage of fresh water. And the dry spells is forecast to continue and increase by almost 20% if we continue with the current scenarios with a negative, with a more adverse scenario.
Right.
So depending on different scenarios presented by you, Cyprus will also have the increase in the number of days and nights of heat. And the change will be especially noticeable during the nighttime, because I can see that the increase of tropical nights is faced by 60 to 120, is predicted to be between 60 to 120%. It's clear that long-term planning will be essential. So looking into the future, what are your top priorities or hopes for improving Cyprus's water resilience in the next 10 to 20 years? And what actions or innovations give you the most optimism?
Thank you, Olga, for these questions. Before going into that, let's continue briefly to look at current conditions now with particular regard to water. Now, this is a global map of water scarcity or water availability. And you see blue and light blue countries, and then you see light yellow, yellow and orange countries. Orange indicates strong water scarcity. Water scarcity in this case means less than 1,000 cubic meters of water per person and year. Now, what's obvious in this slide is that the Mediterranean or the MENA region stands out as a particularly strong water scarce region. In other words, most of the countries, including Cyprus, suffer from very low availability of water from precipitation. And that's something that is the present, but as we see and as we have seen, this will continue to worsen as we go along. Now, to summarize, in terms of what we're expecting and what we're seeing already, one thing is clear: climate change is real and it is happening now. And not only in Cyprus, but as we've seen in the Mediterranean, and of course in other places on the globe as well. As we said, the Mediterranean basin is considered a climate change hotspot. It's also a water scarcity hotspot, as we've seen a moment ago. And this has a number of consequences. We've seen that we are expecting hotter and longer lasting summers. We see that we are expecting reduced rainfall and therefore an increase in water scarcity. Something we haven't talked about are dust storms, which are a real threat, for instance, to human health. We're expecting an increase in the number and intensity of dust storms as well. And last but not least, we're expecting changes in biodiversity. That's to say, the number of species are expected to decline. And this decline in abundances of animals includes useful insects. And that brings us back to the Rotary project, the pollinator project that you mentioned earlier, Olga,
Yes,
because they will be affected as well and are being affected already.
already.
Now,
True.
if we take a look at the issue of what can be done and how can we deal with water scarcity in Cyprus, we are looking at what's called water resilience. And this includes a number of important measures. And this list that I'm giving now is by no means complete and comprehensive, but I think it lists the most important things. Now,
Yes,
we
please.
haven't talked about that, but water is mainly used in Cyprus and in the Mediterranean in general by agriculture. Farmers need water to water their fields because the productivity increases dramatically for plants and for plantations that are being irrigated in comparison to so-called rain-fed agriculture. Now, what we need to do is we need to really increase the irrigation efficiency. And that can be done through what's called smart agriculture. In other words, we need to see and monitor plants even on an individual basis and see where are places that need water and where can we save water. And the plants that need water need to be given water in a very concentrated and clever way. Now, coming to the sort of daily life of the inhabitants and of us people, one thing we should be and can be doing is rainwater harvesting. Now, I said rainfall is scarce. However, the rain that falls often goes away and actually is being let to the sea rather than being saved. Now, we can use our roofs and our flat buildings to collect the rainwater and put them into cisterns, something that our forefathers have known long time ago and have practiced, and which has become sort of out of fashion. But we should go back to that and should do rainwater harvesting. Another field that is often overlooked is what's called gray water harvesting. In other words, the water that we're using, for instance, for dishwashing, could be reprocessed and could be turned into water that can be used, for instance, for irrigating our gardens or our lawns. So that's another thing that we can do. The Looking at the issue of households and water. In order to look at the issue of water saving at the household level, let's take a quick look at what is used in households in terms of water. Now, the typical domestic water consumption is seen in this pie chart
Yeah.
on the right. And what's obvious is that about two-thirds of the water that is being used in households is used for toilet flashing, bathing, washing, and garden irrigation. And that's, I think, a big potential where we can do water saving. And we should do water saving because if our taps are always running, eventually they'll dry up. Now,
Correct.
um, looking at a broader issue of water and water availability, um, we can look at more innovative ways of producing or of generating drinking water. And that's something that we have pioneered at the Cyprus Institute. And the little picture, the little schematic in the lower left corner um, indicates what is happening and how we're going about to do that. We're using solar energy to heat up a thermal energy storage tank. And in that tank, we're having molten salt, which is sort of strange, but it's a substance that has a high heat capacity and can be heated up easily. And this heat that we're storing is then extracted to run a steam turbine. And the steam turbine is actually fed um, by the water that we are extracting from the sea and is turned actually into electricity. Now, the heat that is being stored and the extra heat that is still contained in the steam is used in a so-called multi-effect distillation unit to produce drinking water. So the innovation lies actually in a double benefit that we're getting from this kind of technology of producing electricity and drinking water in the same plant. Now, uh, this is not just science fiction, but as I show you in the next slide, um, this is actually real. We have uh, produced and we have constructed a still growing experimental facility on the shores of the Mediterranean in southern Cyprus. Um, we are having, on the one hand, a so-called heliostat field. Heliostats are just mirrors that can be moved around to reflect sunlight, and the sunlight is being reflected onto a point where the salt that I talked about a moment ago is being heated and put back into the storage. Now, and then, as I explained, this heat can be uh, utilized to produce water and electricity. However, we've gone a few steps further. We have uh, also constructed or set up a photovoltaic array to also produce electricity that can be either used for desalination or for other purposes. We have also employed solar dishes, which are other devices to produce electricity from sunlight. Um, so we're actually having a number of components that form what we call the Proteus microgrid. On the one hand, we have the heliostats, or what's called concentrating solar power. We have the solar Stirling mirrors or the solar dishes. Um, we have photovoltaics, and in addition, which isn't being seen on the slide because it's a bit outside, we also have a wind turbine. So using a multitude of harvesting devices to harvest and utilize solar energy. And remind you, solar energy is free of charge. It doesn't cost you anything. Now, as we all know, though, sun doesn't shine 24 hours a day. So in order to utilize solar energy effectively, we also need storage. I already talked about thermal salt storage. In addition, we're using battery storage to store the electricity that cannot be immediately utilized in the desalination unit. Now, all of that leads to polygeneration of water that I mentioned before through desalination. It is being used to produce electricity, and it can also be utilized for heating and during wintertime, but more importantly for cooling, for space cooling, because that's something that we will need, as we explained earlier, during the hot summers. So I think overall, what can be seen here is that there are a number of options that can be employed to use water more safely and to react wisely and effectively to an increasing scarcity of water. And I hope that we will be able to really do this and that people will understand that it's also their responsibility to help increasing water resilience on Cyprus.
So we've covered the past, we assessed the present, and we had a quick sneak peek into the future, including a brief discussion of some innovative solutions aimed at improving Cyprus' water resilience that are being tested these days. Thank you, Professor Lang, for this thoughtful discussion and for your long-standing contributions to environmental research.
My pleasure, Olga. Thank you.
It's been great to speak with you again, especially on this meaningful day of global reflection. And good luck to you with your project, and we hope that we will see it being implemented on a large scale in the soonest. And yeah, let's hope that the insights that were shared today translate into real action, because the time to act is now.
Thank you very much indeed. And I couldn't agree more with you. Thank you, Olga.
Thank you, Professor Lang.